Have you ever stopped to wonder why people put salt on the roads in the wintertime? Well, as you might have guessed, the salt actually melts the ice that's on the road, which makes it nice and safe for people who are driving or walking on the roadways. Sadly, however, it bothers my dog's paws, but that's okay. She has booties. So we're gonna watch to see how that happens, looking at water itself. And this is called freezing point depression. So when you have a glass of water, I'm a big fan, I love water. What it's made out of is a whole bunch of little molecules. And in water, the molecules are just kind of randomly moving around, free to do as they please. So let's see, I have 6, 7, 8. So all the water molecules are randomly moving in the water that you're maybe drinking today. When you put it in the freezer, it turns into ice. And what happens is that the water molecules actually arrange to be in very structured lines. And when they do so, they kind of connect in a way. It's kind of like they hold hands. So I'm going to draw a green line to show that they're interacting with each other. Maybe they're holding hands. So this is our ice molecules. They're very rigid and structured. As you can feel if you take an ice cube out of the freezer, ice cubes are pretty hard, right? So let's take our ice cube with these rigid molecules that are all holding hands, and let's add some salt. I'm going to represent salt, I guess, in green. I clicked red. Oh, well, it's green. Oh, wait, I just made that in red. Hold on. We're going to do red. There we go. So our salt is in red. So I'm going to just add some salt right onto my ice cube. This is me sprinkling salt on. Salt. And the salt, these red salt blobs, are going to get right in between the water molecules. They're going to like karate chop their hand holding. They're going to break the interaction right between the two water molecules. So the salt essentially stops water from interacting with itself. So what happens is you have that ice, you added salt, and now the water molecules look like this. They look back to our original model where the water molecules were kind of randomly around and the salt is also in there, but it's stopping any hand holding between the water molecules themselves. Like this guy, this red guy, is right in the way between these two guys coming together. So essentially, salt stops the freezing of water. And the interesting thing is that you could actually use something other than salt to do this. You could replace sugar instead of salt also. So you could try that for yourself and put sugar outside on some of the snow that's left over. Come back later and see if it's melted. But that also works. So this is called freezing point depression. And what it means is that, let's say normally when you look at water, water freezes at 0 degrees Celsius. That's freezing, it's very cold. And when you add salt or sugar to the water, it actually lowers the temperature at which the water freezes. So maybe now it's like -5 degrees Celsius, which explains why the ocean doesn't actually freeze very easily. I've never personally seen the ocean completely frozen around us, but around us I have seen lakes frozen that don't have salt in them. So this is freezing point depression. It's going down. It's harder to freeze salt or sugar water.